In March 2015 at the MicroHAMS Digital Conference in Redmond, Washington, Bryan Hoyer, K7UDR, gave a presentation about the convergence of TelCom and NetCom networks. At the end of that presentation, he took a few moments to share with us some updates about the projects coming out of Northwest Digital Radio. He gave us an update on the UDRX. UDR stands for Universal Digital Radio. In addition to that, he gave us some history and background on the DV3000 that plugs into the Raspberry Pi that allows you to enjoy D-Star radio, as well as the ThumbDV. I hope you'll enjoy his presentation. Join me now as we enter Building 37 on the Microsoft campus in Redmond, Washington.
Talk about who knows about the UDRX. I got some new faces, good. Who is on the pre-order list? Same people, good, all right.
Anyone that knows about it,
Pretty much. So the UDRX, this is a product that we announced back in 2012, redesigned in 2013. Yes, it was 2012. We announced it to be shipping end of that year, but at the end of that year, we killed it and redesigned the whole thing, and so now we're about 20 months late on getting that delivered. But it hasn't stopped, and people keep asking me, when's it going to ship? And I've stopped giving dates because I've been wrong so many times and it just gets old. But what I am giving is progress reports. I gave one back in September and said we had some significant things left to check out. Most of the hardware and software is in place. You've probably seen the receiver tests, they work good. And we also have the transmit stuff going on. Back last year I said, I suspect I'm going to have to do some work on the PA section. And we may have to have a minor board spin for that. I was right, we had some issues there. One of which I expected, it wanted more ground screws to keep that module stable. The other one I didn't. Because I didn't know if you looked at the power amplifier input, if you turned around and looked backwards into the driver, that you could actually see all the way through it to the SAW filter. And the SAW filter is a very bad match outside the band. So I created an oscillator at below 430 or above 450. So the solution to that is we had to add some attenuators. They were already in there, we had to rearrange them. That's out the prototype being checked out. We also did some checking with a similar problem on the output filter to make sure that the in-band SWR kept the power amp module happy. So that's now been done and prototyped, and those things are moving forward. So the receiver section has gone through the initial tests, and this is a full digital receiver, ground up, multiple phase lock loop clock systems. And the last test we ran was we injected signals off carrier. So we're coming in 100 hertz off, and we're looking for the lockup time to acquire it. If you look at the D-Star spec by way of example, and my packet friends will remember that TNCs all have that parameter for how much wiggling do you do on transmit before you do any data. And it's usually a number like 128 or something. So if we're 100 hertz off, our current design is locking up in about 11 bits. That becomes significant because we often talk about turnaround time, and we talk about, as we heard with DMR, we talk about well, you have the time for the power amp to cycle up and down, but if all you're going to do at the end of that is send lots of bits out, D-Star says 660 or more, then you've burned all that time and you won't be able to do the things that they're achieving with DMR, which is pretty impressive. So that piece is working. It still needs the final integration. And one more thing I'm going to allude to, no guarantees at this time. When we started this project back in 2012, there were no Raspberry Pis. There was a project, it's hard to imagine, but there was a time before Raspberry Pis. There was a thing called a Shiba plug, remember those? That was the first inexpensive single board computer, plugged in a wall AC, cost $100. We actually used that for initial software testing and then built a custom version of that. Those boards, we still have them and they work fine, but those processors are getting old. And now there's a flourishing community that's grown up building inexpensive single board computers. So our radio card has a 40-pin header, just like the Pi 2. The pinout's different, so I have this choice. I can use their pinout, and there's 3 million of them, or I can use my pinout, and there's 25 of those. So we're going to change and use their pinout, which opens us up to using an off-the-shelf computer module. It'll still be in the same case. It'll still be fully integrated. It also means that as those modules change, because they get a new one every 6 months to a year or two, we'll be able to ride with that as long as the connectors maintain the same functionality. So no commitments on that yet, but it's likely if we start shipping, we'll be shipping with an off-the-shelf computer. Candidates are Pi 2, BeagleBone Black, Odroid's missing I2S. There's a couple other ones out there, but we're looking into doing that. Any questions on the UDRX?
What do you think your processor and memory requirements are for the embedded computer?
Well, the one we have now is a 800 meg processor, single core, and we have a 1/4 gig of memory. And all of the current off-the-shelf ones are much faster and much more, which we don't need, but don't you always want the current version of, as we talked earlier, I just got a new Mac. Every 3 years or so, they start to get a little long in the tooth. And people will keep adding more features onto it and trying new things. And we want to have a platform which can grow with you. So that's what's driving this decision. That combined with the economics mean I can buy quantity 1 Pis cheaper than I can build quantity 1,000 single board computers of my own design.
So is there any other questions about the UDR? Steve?
So are you proposing essentially a UDRX Pi like the TNC-X Pi that'll just be glommed onto a Raspberry Pi?
There will be no glomming. It'll be
Technical term, glomming?
It'll be bolted into a case in the heat sink where the current one is, internally connected and shipped as a unit. If you say, can I buy the radio and provide my own Pi? The answer is yes, but you'll pay the same price and I won't warranty it. Because Pis are plentiful and inexpensive.
Oh, sorry.
Are you aware of the Raspberry Pi Compute module?
Yes.
Okay, they've committed to coming out with a Raspberry Pi 2 equivalent of the current one.
Yes, the issue with that is I then have a lot of work to do to duplicate all the outside world connectors and interfaces and test them and certify them, so it's less attractive. The Pi 2 looks pretty good because it has what I have. It's got a 40-pin header to the radio. It's got 4 USB ports and RJ45. So it's got about the right form factor, as does the Odroid. The Odroid doesn't have I2S. I2S is the specification which drives the audio codec, and they don't have that, and I need that. So although it's probably on the board someplace, I don't want to start hacking things up. So we haven't finalized on it, but that's what we're looking at. Any other UDRX questions?
So to summarize, you basically are not in the embedded computer business, but in the radio business.
Yes, I never was in the embedded computer business. I built one because I had to.
Right.
And over time, economics always wins. I can give you a better solution at a lower price point by buying an off-the-shelf module, with the added advantage of when they come out with another one, we can go, okay, we'll take the case apart, throw this one away, plug the new one in, let's keep going.
Repeat and rinse. Any other questions? Yes.
You have to wait for Kenny.
Sorry.
one ahead of you. You're in the queue, though.
Steve, K7CCR.
Hey, Steve.
Is the DV3000 still going to be compatible with this newer RAV of yours?
That's coming up next, and the answer is yes.
Okay, thanks.
Can you expound a little bit more, please, on how this gets us away from hard allocation of voice channels? I'm sure I should get it, but I don't.
Okay. So first off, DV, which is, FDM and everything else, can be done on this platform. And if you add the DV3000 to it, which is the Ambi chip card, which is the only proprietary piece of D-Star, you could add it to this. One customer said, I like the fact it's an add-on, so I don't have to pay the Ambi tax. And some people view it that way. I view it as not everybody needs it, so why burden the cost of every radio with that? This also does packet, and packet at 9600 and up, and we'll get this past 100 kilobits per second. When we get into network speed, there's some minimum speed at which the whole network starts to work for voice and other things. It's probably up around 19K. You probably have enough excess bits and timing to get streams through. And at that point, you're no longer hard allocated. A lot of protocols will go along with this, but we won't invent them, we will adapt them. So IPv6 looks very promising for the radio side of the network because it has a few features built into it. One of them is header compression, which means that we create an ad hoc network and Kenny and I hook up. We exchange long bit streams of IPv6 addresses. And then we go, but from now on, I'll be Bryan, you be Ken, and we'll just talk that way. So we get the packet size down. There's also real-time protocols built into IPv6, which are supported in IPv4, but they're more built into the protocol. So that's a promising area. Once again, the ARETF will be a big player in talking about how do we do that, what kind of gold codes do we add at the beginning for synchronization, because you still need an on-air wrapper for any IP-type protocols. New modems will get supported. We heard about FEC and DMR, FEC. So I think the first big commercial use of FEC was in the CD player in 1984. That's the first time we saw a large scale. And the reason it didn't come earlier is because at the time, we were limited in processing power, because you got to figure all those bits out. Processing power has gone through the roof. Now the question becomes, how quickly can we adopt, and what types and quantities of FEC will be best used in radio networks? We have something really valuable here. There's a bunch of you guys. And if you build a soft product that you can update, you can download something, and it's all open source and free, and you can try it, and you can report your results, and then collectively we'll figure out what is the right amount of FEC. Now, some people have said, oh, we should just make it adaptive. But my personal opinion is that'll be chasing the problem, because links are generally good and they get smacked once in a while. And if you start making your FEC vary, what you'll end up doing is when you get smacked, you'll still get smacked. But then you'll add a whole bunch of bits to it to solve a problem which is now behind you. But only real-world testing will give us good data on that. I had lunch with Phil Karn down in San Diego a while back, and he said, for every modem I've designed, the first thing I ask is, characterize a channel. And he goes, and they never do it. They just tell me, oh, make it work like this. So that's an opportunity that we can do as amateurs. We can actually do things better than the commercial guys do. So the commercial guys do commercial products, then they throw them over the fence, we use them, adopt them, make them work. But they're not really designed for us. And it takes us out of the equation. You know, getting back to Kenny, get involved, build a kit. And your friendly Amazonian, that was a wonderful thing with that loop antenna. I mean, that's real engineering, that's doing good stuff. So I want to see more involvement in that. Yes, sir, what's your name?
I'm John.
Hi, John.
I just wanted to dig into another little aspect of the question here. You know, what Bryan mapped out was that for a given budget of ones and zeros. You can use them in different ways. And if you have a radio, we're limited by the FCC regulations how much bandwidth we can use on the band this radio is allocated to. There are other bands that have different rules. That figures out to 100 kilohertz wide, and we can get more than 100 kilobits into that by a little bit. A single voice channel, only when you're talking, can be done on AMBI in 3,600 bits. A lot of 3,600 bits fit in 100 kilobits.
Yes, to that point, earlier when I asked about how about pushing photos and videos across DMR, the correct answer is it wasn't designed for that. There's 900 bits or so left, and yeah, you could SMS or something. But if I've got you on the phone, I don't need to send you a text, do I? So it's a different use case. Conversely, if you're not talking, in current implementations, you can't use the voice bits for anything. That's a limitation as far as I see.
Also, I think we're only limited to a symbol rate, not a bandwidth. Not 7%.
Almost. It's a symbol rate, not a bit rate, but there is still a bandwidth limitation.
Yeah, the reg is both.
So it's a 100K slice and a 56K symbol rate. But yes, we could do 2 bits per symbol, 3 bits, 4 bits, 8, 16 clam. We could explore all those things.
Why don't we let Bryan move on to the ThumbDV?
I got one in between. So this is a product we launched at Hamvention last year on a bet. I was spinning the board and I wanted to move software development forward. And I told John, I said, if I put our board on a Raspberry Pi connector instead of my proprietary connector, at least the software guys could start playing with it. And he said, I could sell those. And I said, who the hell would want that? So I said, fine, I'll go commit to building 64 of them. He says, we'll sell out at Dayton. So I built 100. And he said, well, now if we don't sell them, it's on you. But they sold out in 4 days, which answers the question of people are looking for a way to experiment. And it has the newer AMBI chip. And if you were on our blog last week, I put a post up about, does the AMBI 3000 sound better than the 2000? And the answer is, I don't know, maybe. Under some circumstances, it can. But just like being able to change the processor out, don't you want access to the newest technology? UDR stands for Universal Digital Radio. We're also trying to pull people back together. Here's one radio that can do D-Star, and there are people interested in that, but it can also do packet. And it can switch back and forth. And this encoder chip, this vocoder chip, also supports D-Star, DMR. They all use the same chip. So now it's also a way to get one package that could do D-Star or Fusion, assuming the software's there to support it. And there's been some progress on that recently. Now let's go to the ThumbDV. So last September, we were approached by a well-known HF radio manufacturer that said, is there some way we can put this DV3000 card into our radio? And I said, do you have a Raspberry Pi in there? And they said, no. I said, do you have a Linux computer? And they said, yes, we do. I said, well, what do you have laying around to connect to? And I said, we got these USB ports at the back we don't use. And I said, I'm not just going to build another DV dongle. But John said, we could sell those. Because John always says that. So
He's a marketing manager.
he said, so we built a bunch. And we launched it just before Christmas, and we've sold 250 of them to date. And John's going to talk more about what it does. But it's a little platform chip with open source software. There's at least 2 applications on D-Star now. There is some DMR work being done. Are you going to talk about that in your speech?
No, just basically people are using some open source software to feed DMR and ECHO 25 Phase 2 to our chip to get the output back out.
So here's an interesting experiment. We could flip a switch and run the more advanced protocol used by DMR and Fusion over the D-Star network and listen to it and go, well, what do you think? I mean, as amateurs, aren't we experimenters? So what this is doing for us as amateurs is, we're trying to pull it back together. We're not being forced into pick which tribe you want to belong to and then sign your allegiance here. John will talk some more about that on his pitch in a little bit. So that's the DV, the ThumbDV. And how many people have them already? Yeah, a fair number. We're going to give one away for the, whatever it's called, the raffle.
Door prizes.
Door prize.
Be a door prize.
Going to become a door prize. How am I doing on time?
You've got, say, 5 minutes. We can take a few questions.
Okay. Are there any questions about what I've talked about so far? Any other general questions about other stuff?
Anything? Bryan has left us speechless.
Thank you very much, Brian.